Okay. Well, oh my God. So let's kill this one. Audio input capture 3. So we should have. Oh, great. Now I've got echo. It's picking up from here. Music interface is all I need. Kill that one. Is that better? No, still a little bit of echo. Okay. Let me just get this. Oh, geez. Echo City. Output. Do I need a direct? No? Okay. You can hear me. Okay. All right. So, you know what it was? Oh, geez. Whatever. I won't even worry about it. It was. Let me kill this. That's it. No, is that not it? Why am I getting... So... Oh, what a nightmare. Okay, so... Okay, finally. Okay, so now I can hear myself. All right, cool. So what it was, I guess earlier this week or something, as there's some pop-up on my laptop, and is like the microphone thing is like, do you want any device to be able to access your microphone? I was like, no, that's lame. And I hit the slider. I was like, I don't want any whatever random pop-up to access my microphone. And I guess that just turns microphones off for everything all the time. Like, I just don't want random internet stuff having access to my microphone, not, you know, this custom setup I have over here with like its own, you know what I mean? Windows is just like hot or cold like that, I guess. And then it takes 20 minutes to find the setting menu for the big slider for the microphone to say, hey, you know, I want to use I don't want to use a computer microphone. I want to use a different microphone. I guess it's all tied into one, whatever. So sorry about that, guys. Eventually I'll get the hang of this. It's more complicated than it probably looks, but I guess I started a couple minutes early, so we really only wasted like 15 minutes on that. You know, not quite ideal, but I can stay till 6 or whatnot. So nobody heard me except me earlier. I got a couple questions lined up. I got some good questions via DM and some of them by comment on YouTube videos or whatnot. I think what I was showed earlier, I have a video coming later this week, right? I was trying to show you this just about the MMC symbol. So I'm pretty happy with this. I think this is going to be pretty informative, for those out there that are just getting into the GD&T game. So the first thing I want to talk about is this datum feature symbol. Let me make sure I got that right. Okay. So I'm going to find a part with some round features, and what the DM kind of had in it was somebody made a drawing. And you know what? I don't even need that. Say somebody sends you a drawing and it's just, a cylinder, no big deal. Maybe there's like a tapped hole going through it. And then the datum feature symbol is like over here. Right? That's not the place it's supposed to go. Typically, if this was a square part, right, just some kind of rectangle or whatever, if we put the datum feature symbol and it's not in line with the dimension, it applies with the surface. If the datum feature symbol is in line with the dimension, it applies to the center of the part. With the cylinder, that's not a thing, right? We can only apply it to make the axis of that cylinder the datum feature. There is no applying it to like a tangent line on the outside of the cylinder. Normally, you could just scratch this up to, okay, whatever. They just meant to put it here. But, you're going to run into problems with that when you start interpreting what the designer meant to do. it's possible they were trying to use datum targets. There is a technique with datum targets where you can have line contact on the outside of a cylinder. You wouldn't mark it like this, but there is a situation where you could say, and I drew that one too big, but I'll draw another one over here. Say you have a part like this right up here in this corner. Designer could kind of specify, hey, I want line contact on these 3 spots, right? And they would call that out with datum target symbols. But it doesn't mean the same thing as just putting the datum feature symbol offset. And I want to say this question, they had like a symmetry or something involved, and it didn't make sense because they had put this datum feature symbol off to the side. I want to say, yeah, the part, let's say it was something like this. Oh, great, stupid Wacom. All right, that little writing pad kind of remembers what you just wrote, and if you hit erase, it'll erase anything you're doing all at once. So here's a simple little part. I think, yeah. What they had going on, they had like a datum A here, but it wasn't in line with the dimension, right? And let me just, oh no, man, great. Okay, so say this is some dimension, right? They had their datum feature symbol hanging out over here, but they also, and in this case, they're using symmetry, which is weird. So they're like, oh, okay, by the way, this is symmetric to datum A. Well, that again leads you to like questions like, okay, what is datum A, right? If you took it literally, right, you would have to say this applies to this surface, right? So imagine you're, like a witness at a trial or something. You can't sit there and be like, oh, well, I'm pretty sure the designer didn't mean that. Like, you're going to explain like exactly per the standard what that means. Now, I'm not saying that applies in all situations, but I just want you to know that this does not mean you're applying it to the center plane. It means it applies to this. And then it makes this symmetry not make any sense, because now you're saying, well, this feature right here, the center of this feature is symmetric to this over here. Right? That just doesn't make sense. And that's why you often hear, right, hey, just use position instead of symmetry. With position, it can make more sense, because then you can just have a basic dimension, right, locating this feature relative to this feature. No big deal. It doesn't look nice. Ideally, what they probably meant was, hey, just put that right here, and then symmetry or position works just fine. Symmetry's been removed from the 2018 standard. As long as it's an option in CAD programs like SolidWorks, people are going to keep using it. For the uninitiated, it makes logical sense what it does, right? Whereas position does not make sense. So if you've got a designer or an engineer or whatever, and they're not hip to GD&T yet, they're going to see that symmetry symbol and be like, oh yeah, that is the ticket for this situation, right? That's what I want to do. And it's probably the same kind of people that make mistakes with this datum feature symbol. It is really, really important to get that right. I know it seems nitpicky, and a lot of things are nitpicky, right, with drawings, right? If I have a student that runs their extension lines into the part I got to say something, right? I can't just let that go. But I wouldn't reject a part, I wouldn't run up the total of a quote or say, hey, this drawing is completely wrong. That's just like a note. Like I typically wouldn't take points for that. But if you screw up the datum feature symbol, you're really setting yourself up for problems in the future. Oh, that's interesting. So here's a comment. I read somewhere that if the datum is after the dimension, it's the same as aligned. Maybe that's a GPS thing. I'd have to look that up. That's pretty interesting. It's not ASME thing, I can tell you that. What I recommend in ASME, if you have a feature, right? Say you want this side of this little box to be a datum plane, and you're going to have a dimension like this up here, I would say flip it to the inside, right? That way, even if your CAD software, glitches or whatever, it'll never be in line with that dimension. But that's really interesting. I'd have to look that up in GPS. Okay. Oh, so here's another question. Currently, my team doesn't specify a standard on our drawings. Is this usually required on drawings, or would each manufacturing? No, it is required for sure. I would definitely pick one. I would, if you're based in the U.S., just put ASME Y14.5-2009, right? If you don't have any other, reasons to go with that, right? It's not the newest version, but it's the most common version, and it's the one shops are going to be most comfortable with. Generally, I mean, there might be some shop that won't quote. They only want the newest. I doubt it, right? This is the one to go with. I've heard like sometimes a company like their, I don't know, like marketing department will be like, well, we use ISO 9000 or 9001, whatever those standards are, so we need to use ISO for engineering drawings. That's not really true, right? You can mix the systems. They're like not totally different things, but ISO 9000, 9001, it's like, I don't know, bookkeeping standards. You could use those and ASME for your drawing. So if you're in Europe or outside the US, maybe look at ISO, GPS, but you're not going to get as much support for that as you would ASME, for free on the internet, like right now, right? I doubt anybody is doing an ISO GPS live stream. Maybe, I don't know. If they are, let me know. That'd be interesting. Okay. Hey, all right. Cool to have some people from India in the audience. For my Indian audience, makes up like 20% of my viewership. It goes United States, India, I think Canada, UK, Mexico. Someday I'll do one earlier in the day. I know, India Standard Time, a lot of time zones and a half ahead. So I know if I do like 7 in the morning Eastern Standard Time, it's like, I don't know, 5 or 6:30 there. So I will get to that eventually for that audience. Okay. How to draw. So let me move to the next question I had. Oh, let me check here real quick. Good on time. Oh, jeez. So we go back one in the studio. Dashboard. Community tab. Comments. Oh, I keep getting this question with position. So the question is basically, what about position with no datum references? Like, what's going on with that? It's not, yes, super specific about what situation they're seeing it in. I can tell you this, in ASME, you can use position only with features of size, and bounded features, which is like an enclosed feature of size, but I don't know, irregular, I guess. It doesn't come up that often. In ISO GPS, you can use position on a surface. So maybe in ISO, there's some spots where you can use position without a datum reference. And ASME, there's only one case, and it's with coaxial cylinders serving as a primary datum. Okay. So if you have, and I did make a video about this before. So if you have like a dog bone shape, there's a couple ways to do it. One, you could just say whatever the diameter is. You could use the continuous feature symbol, and that essentially extends rule number 1 to cover both features. Or you could do 2 times. With continuous feature, you don't have to enumerate the number of instances for whatever reason. I mean, I don't really agree with that, but it's like a semantic thing. It's like, okay, it's continuous feature, aka one feature, aka you can't do 2 times. So the other option here, right, is we could do position 0. It doesn't have to be 0 at MMC, but that's the easiest graphs for now. With no datum reference. So what is a position doing? It's controlling the coaxiality of those cylinders. Nothing else. Well, Runout can sort of do it, but then you're controlling the form of the surface. Profile could sort of be used here, I guess. You're going to get weird looks if you use profile on cylinders. These almost mean the same thing. I would say they're identical, right? So if we look at our MMC, it's 1.02. Our LMC is 0.98. The bonus tolerance here is 0.04. The total size tolerance here is 0.04. There's really not that much of a practical difference between these two methods. I think design intent wise, I don't like continuous feature. I don't know. I don't like using that symbol very often. I'm sure it comes in handy and people will disagree with me there, but I think the position is going to get the design intent across a little bit better in this case. Yeah, so that's the only time. And ASME Y14.5 that you can use position with no datum reference. It's got to be coaxial cylinders. That's it. I almost wish I like it better than continuous feature, but I almost wish they get rid of it. So when I'm teaching position, I can say position always has datum references, but now I have to say always has datum references, except for this one time when it doesn't for no reason, right? When you could just, if you think of it from ASME's perspective, well, why even have this if you have continuous feature? When you rolled out continuous feature, you should have gotten rid of this position thing, so that when us GD&T teachers go out there to teach it, we can make blanket statements easier and not have as many exceptions. Those of you that have done a GD&T class know what I'm talking about. Okay. So let me answer this real quick. Profile of a surface. With no datum reference. I can understand how this is a little weird looking. You would think it does something totally different than flatness. It doesn't. If it's If it's a flat surface, flatness and profile mean the same thing in this case. There is no difference. And in ASME, CMM should give you the same results because the profile isn't locating anything. Now, I can tell you, at least Calypso doesn't like this. It gets upset when you try to do it. It wants you to give it datums because it's programmed for ISO, I guess. I'm not sure about Pisademus. Someday I'll talk to somebody about it and see how Pisademus would handle this. But it's totally legit, right? It just means you've got two, parallel planes that aren't affixed to any datum, so they're free to float. Well, I say parallel planes. So the tolerance zone for profile is defined different than flatness, right? So flatness is two parallel planes. The minimum size is the actual, and the maximum size or whatever is what's in the feature control frame. With profile, it's defined different, right? It's defined as being perpendicular at all points. So what I'm drawing is little lines here that are 0.02 long. They're perpendicular to our true profile, right? And let's say we're just looking at this surface right here. Right, this is our true profile. Those little lines are centered on the true profile. They're perpendicular to it. And now we connect all these little dots, and that's our tolerance zone, right? So the actual surface needs to be within there. So functionally, it's the same thing as having two parallel planes. It's three-dimensional. I said line, but it is three-dimensional with profile of a surface. As far as which one to use, I mean, probably flatness, I guess. I don't know. For teaching purposes, I like to use profile because it makes people think. And I could see flatness going away. GD&T wise, I could really see it just being position and profile and some amount of time. All the other ones are just some version of profile. Okay. Got those two. All right, let me look at the live questions here. And actually, let me check, make sure this is running on, is it LinkedIn? View on LinkedIn. Cool. So that's working. Wow. Oh, wait, 1300? Is that this one? Okay, that's me. I think. Okay. That looks good. Coolio. Okay, so let me read this out. Brian, I think I answered yours about coaxial features just a minute ago. Let me know if there's anything else you wanted me to cover there. So let's suppose we have a subassembly that is assembled in a global assembly, final product. Subassembly touches two datums of the global assembly, fixation done by screws, and this makes part of the global assembly, and now comes the question. In the factory, the subassembly is fixed first with screws on the table, mounting device, and is given as datum A, and it makes it the first datum, and after that comes the assembly on the other two datums. Is it wrong once the table mounting device is not part of the global assembly and shall not be considered as a datum because it's not part of the final product? Ooh, is it subassembly is fixed? Yeah, I'm having a tough time kind of imagining that. You might have to send me like a hand-drawn sketch or something. There are times when you're using non-functional datums for whatever reason. Sometimes the functional features of the part just don't make any any sense for what you're trying to do, and you just need like a big surface. Also, in the 2018 revision, for the first time, they showed checking things to an assembly. So I think the picture they have is like an electric motor assembly, and they're checking the runout of the shaft, and they're just identifying, piece parts, I guess, like the legs of it as datums, basically just to check that one feature. So it's not out of the realm of possibility to have a different datum scheme for the assembly as a whole. I mean, that's fine, but yeah, I'd need to see a little bit more about what you have going on there. Okay. Oh, here's a good one. Should circular runout be attached to the diameter or not? I've noticed many drawings where it's attached to the diameter. That's super interesting. So what the ASME has been doing over the past, 30 years or something, is trying to separate features of size versus surfaces as far as feature control frames go. So when we apply, position to a diameter, right, the position is always going to be with the diameter, right? And that's kind of like a giveaway that it applies to a feature of size. Even if we're applying drive median line straightness, right, we're going to put it with the dimension. And that's a giveaway that applies to a feature of size. It becomes even more important. Say we've got a pin pressed into a plate, and this is kind of the classic thing for explaining perpendicularity, right? We would put the perpendicularity tolerance next to that dimension, but say the side of this part is perpendicular, right? It doesn't go with the dimension, right? It's a totally separate thing. And that's done for a reason, right? It's just an extra step in making sure something is, applying to the, in this case, the axis. This one is applying to the surface based on where the feature control frame is. Now, there's more clues, one of them being the diameter symbol. But if it applied to a center plane, right, there wouldn't be a diameter symbol. So the only thing letting you know that it applies to a feature of size is that it's attached to that dimension. I kind of harp on this when I'm doing this on a whiteboard, right? So if it's adjacent or hanging out with a dimension, it applies to a feature of size. If it's leader directed or on an extension line, it applies to a surface. Now, I'm pretty sure ASME has outlawed this, where you would have, let me do a little erasing here. So say we wanted to, for whatever reason, apply a circularity to this. I know you'll see this all the time in ISO. And ASME, I forget if it's completely not allowed or if it's just, not recommended. I know it's not recommended. But because this circularity applies to a surface and not the axis, we really don't want to put it with the feature control frame, with the dimension. What we would like to do is lead or direct it, just like this perpendicularity down here. Same thing with cylindricity. And for a long time, even in the standards, I want to say, do I have it handy? I'm fairly certain it shows runout with the dimension in 1994, and I'll find out for you in 1 second here. Well, maybe I misremembered. Huh. No, never mind. I totally misremembered that. Oh well. But yeah, with Runout, I think it's still allowed, but it's not recommended to put it with the dimension for this reason that I've kind of outlaid here. With a Runout, you're controlling the feature of size, but you're controlling the surface of it. So you can achieve coaxiality. It's not like cylindricity where it's totally unconstrained, but you're directly controlling the surface. So in that way, it's very similar to like profile if you constrained it to the datum axis. So hopefully that answered your question. That's a great question. And, ASMEs can, over the years, kind of, I think, trying to get away from putting feature control frames with surfaces. Okay. When using SolidWorks MBD auto dimensioning, it automatically attaches a circular runout to the diameter. I don't want to disparage SolidWorks or anything, but I don't even know what they're doing. Like whenever I try to use MBD, like it gives me 500 decimal places, and it just does everything wrong. Like it's almost, I don't want to say it's totally useless, but it's like, okay, you're saving people time by putting all of the wrong dimensions and stuff on there. So then I just got to go through and sort through it and delete everything and add it back again. So did it really do any good? Now, I don't know. Maybe I need to be educated on like how it works, and I just don't understand. But the auto stuff doesn't seem to ever help. Okay. Okay, so in a pump assembly, a number of parts are coaxial fix. So anything spinning, like a pump, you got a shaft and bearings. Well, I wouldn't say bearings. The shaft is spinning and maybe the impeller or whatever. I would use Runout a lot. Runout is going to help you with anything spinning quick, because when they go check it, right, they're going to make sure it's coaxial. They're also going to check the form around the outside. So you're going to get something that's not totally balanced, but pretty close, right? It's a very functional check for things that are going to spin. So I would definitely lean on Runout for things that spin like that. Oh, that's a good one. So what about circularity being applied to an average diameter? Wouldn't that control be applied to the diameter and not the surface? Ooh. Let me, I know I just ran into it a second ago, and I might be able to show this on the screen as well. I can just make this a little bit easier. And oh, jeez, what gives? The camera's all screwed up. Okay, 1, 2. All right, here we go. So here's average diameter and Y14M-1994. It's not the most current version, but I don't think this has changed at all. So yeah, you're right. The circularity is attached to the dimension. It's a little weird in this case, right? It still applies to the surface, right? So we're not like controlling an axis or anything. I think, and I'm no expert on average diameter, but I think you could just point this with a leader and it would mean the same thing. Let me actually... And, 1994, someday I'll make a whole video about the quirkiness of 1994. It's, this figure is in like the back of the book, right? There's only like 15 pages left. They put all the form, orientation, runout, and profile in like one big chapter, right? It's kind of wild. Here, let me show you. So here's the table of contents, right? General tolerance thing, that's the same stuff, blah, 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 as 2009. But so we've got datum, location, form, profile, orientation, and runout. It's all one giant chapter, right? I want to check 2009 and see. I want to say they moved this average diameter thing to the yeah, it's in chapter 5 in 2009. And it should be at the end of this little chapter. There we go. Oh, yeah, I'll be damned. So it's still same figure, right? They didn't change it here, which is kind of interesting. And do I have... Huh, I don't know where my 2018 is. But yeah, it's not that big of a deal. All right, going down a rabbit hole for no reason. Okay, so yeah, I think I answered that. The control applies to the surface, right? All right, hi from Brazil. Oh yeah, I guess we're on the same time zone, right? Brazil, is that Eastern Standard Time? I probably wouldn't call it that, but you know, that's yeah, probably easy enough to tune in. Okay, would you be able to explain the difference between the least square math algorithm versus default math algorithm on dimensioning feature control frames on PCDMIS? Short answer, no. Long answer is sort of, maybe. I can give like a real general overview of fitting algorithms. So, right, here's a perfect circle, right? If we're going to measure this and it's perfect, right, we're going to fit, right, some data points on this happy little circle. And if it's a perfect circle, we only need 3. But say we just get 4 for the hell of it. It's going to tell us the exact diameter of this red circle, right? We're going to be, right, super, super happy with that. But in real life, of course, right, if we zoom in, a circle is going to look like this, right? So this is a real mess. Now, the question is, what is the diameter of this circle, right, of this amoeba thing? Now, there's lots of answers. One is to find the largest thing that will fit through here, right? And that can be done physically. Right, and if you've seen a set of gauge pens, you would find the largest little diameter that'll fit through the hole, right? And that's a super common way of measuring things, and that's what would be reported as the diameter. So physically, at an inspection plate, that's how you would find out what the diameter of this is. Additionally, if there's a position control on it, right? Say we've got this little gauge pen. The center of this gauge pen is the axis of this amoeba-looking thing, right? Now, that helps with certain things, but not everything, right? Say this amoeba thing is actually a hole drilled through like super high pressure pipe, right, or tube or whatever. When we're measuring it, right, we put it on a CMM, we want to know how big that hole is, right? What's the maximum? What's the least material condition of that hole? Because what we want to do is report back, do we have any potential issues here? In that case, you want your fitting algorithm, right, to kind of draw outside the lines, if you will. Now, that's a little trickier to do because outliers can cause like a big problem. It depends what the thing is, though. If it's like a high pressure pipe, right, and you have some outlier that's just like a sharp pointy thing, right, that's a big deal, right? You want to take that into account. But if it's just decorative or something, right, who cares about this? Now, you may have heard this term process control. Neither of those tell us anything about the manufacturing process because there's a ton of variability. I want to draw a perfect one again. I want a not perfect one. Let me do it like this. So say we've got a bunch of, gee whiz. So say we've got a bunch of holes, right? And they've got like this, I don't know, thing going on here, right? So with the first two methods we talked about, I'm going to fit a pin. Here's the center of that pin. I'm going to do like an outside thing. Here's the center of the outside thing. Neither of us give us a good read of like what's going on here. What we kind of want is still not 100%, but a Gaussian will give us the average of the high and the low points, and that'll tell you, I don't know, the centroid of all of that missing area, and that can help figure out what's going on in a process. Okay. How does it find? Okay, I can answer that. So which one do you use in ASME? If something's a datum feature, it's got to be in Calypso it's called outer tangential, but not least square is what you want, right? Say you've got a part, right, and the way you would normally inspect it, right, you'd put it on a surface plate and then measure from the surface plate, right? When you tell Calypso or Pisademus to do least square, it's going to do this. It's going to strike a plane through the middle. So just think, if you take a measurement now, right, now you're measuring this, right, instead of this over here. So that's the core kind of message to get across there. I'm not a Pisademus user at all, so I don't know what you would call it, but you want this effect to where you're just looking at the high points. You're trying to treat it like a surface plate. Oh wow, 20 people on. Cool. Okay. And yeah, Alberto, I'm trying to get some trying to do some interviews here and get some people to talk about what they're seeing out there in terms of CMM, get some insight into Pisademus and even Calypso as well. So look for that coming pretty soon. I want to get some different content on the channel, some kind of technical deep dives from some people in the know. Oh, okay. So I got a question about alignment methods. So Carlos is saying, hey, I got two holes in a plate, right? So our classic like light switch looking part. So we're saying 2 times some diameter. I'm going to assume their position something to A. I'm going to go ahead and assume A is one side of the part or the other. And he's saying this is B, and there's probably other stuff to measure from here. So the question is, should I use a circle or a cylinder? I think either's fine. Well, with Calypso, you could do it a couple different ways, really. You could capture each of these features. So you could do like 2 circles and do a symmetry point and treat this as the, say we're going to do it like this, say X and Y. You could treat this as your 0 for X and Y. And that's probably what you want in this situation, because it's going to give you, reasonable results for how far is this hole away from the center of the part. And basically this datum B is in the center. You can make an argument. You could, what some people will tell you is, no, make this the X and the Y origin and use this to set the rotation. You could do that too. I'd really have to hop on a Calypso. That would be fine. At some point, you need a secondary alignment to set this as your X and Y origin. That's the big takeaway for me. So another question would, hey Mark, would least squares be a useful datum approach for surfaces that might wear or break in? That's a super interesting question. You know, if you hop on SolidWorks, the latest version, and their feature control frame wizard or whatever, there's like dozens of things you can put in there, and I'm sure they're all ISO. They're not ASME, I can tell you that. But yeah, you can put in like LSQ and all sorts of like acronyms for fitting algorithms, which is pretty cool. I mean, I don't see why ASME couldn't do that. So yes, in ISO GPS, you can force fitting algorithms on CMM programmers, which I think is probably good. You know, just like the question I was answering, ASME doesn't, they do specify, but it's not modern enough. Whereas ISO GPS, I think they've made it more modern. You know, the designer might want LSQ for the reason you're saying. You know, if you have a cylinder wall or something, you need something different than you need some kind of average approach, not the extreme method there. So yeah, I wish ASME would have some. So what I'm talking about. And this is totally not ASME, so I don't know exactly where they'd put it. But basically in ISO, you can do cool stuff like this. You're like, hey, I want this measured LSQ, not outer tangential or whatever they call it. Okay, so yeah, we're saying the two holes control 3 degrees of freedom. I'd agree with that, yeah. So this datum A takes away 3 degrees of freedom, and these two holes take away 3 degrees of freedom. So yeah, that would be all 6. It's just a matter of getting Calypso to kind of pick up what you're putting down. But it's also important to recognize in this situation, practically, does it make a huge difference? But this means something different than. You see this with like PCBs a lot. You'll see datum B, and then over here will be datum C. And that, yeah, you would need to set up 2 different features. I think, oh man, now I gotta really think. Yeah, so this would be, this would be your X and your Y origin right here, right? You're basically your 0, 0. And then you're measuring this hole to there. So, and here C is just setting rotation. It's a little weird, right? I would recommend doing it the first way, unless you have a really good reason not to. Oh wow, we're already at 6 o'clock. Well, I guess I wasted 15 minutes screaming into my microphone. Let me check. Let's see what else we have going on here. Oh, last thing, I want to chat about this real quick. I got a question about oh geez, let me do this right. 2 times diameter, something, doesn't matter. Position, something, doesn't matter. I'm going A, it doesn't matter. B, basic. So the question was, what in the world does this mean when you have capital B, SC hanging out with your datum references? Well, it means something analogous to saying M or L. And what's going on here is the way it's typically set up is that you would have a profile, right? And say this top surface, bottom surface, whatever is A. You'd have a profile to A. So what it's saying if this wasn't here, there's no BSC. When you set this part up, you've got to have a datum simulator that moves toward the actual part until it, it's fit up. Well, shit. In this case, let me think. In this case, maybe it doesn't. Maybe I gave you a bad example here. 2 times a. Yeah, in this case, it doesn't actually matter because when you set it up, you're just putting it on A and then it goes up against. Yeah, let me scratch that. Maybe that would work, but I still don't like it. So this is this concept is a new thing for 2009. Let me try to think. A good way to explain it. Here, I think I got a better way. Let's go back to a donut. So let's say, and you've probably seen, I like this example because it's so simple. Right, we're going to make this donut position, diameter, 0 mmc, go into A, and let's go to B. Yeah, I like this example a lot more. So let's go to B, basic. Okay. We're going to say once some flat surface here is A, we're going to say this diameter is B. So what this, well, let me back up one step. So if we just have B here, right, this means it applies at regardless of material boundary. So when we go check our donut, right, here's a little version. We've got to capture it, right, in some kind of thing, right, a chuck or a collet or whatever. We've got to have some way to restrain it. And whatever collet or chuck is going to have an axis, and we're going to compare that axis to the axis of the donut hole, okay? If that sounds like a lot, we could use the MMC symbol, right? And modify it at maximum material boundary. And what that does for a donut, right? Now, this MMB is set to 2.02. So now our part, diameter 2.02. Basically the maximum material condition or the virtual condition of the datum feature. So now our little donut can rattle around in there. And what we would do is set a pin right here to the virtual condition of the feature and just drop it in. Okay. Now, what the basic does is just set this at the basic dimension. Now, I know this isn't literally basic, but I would take it the same. So set that to basic. Now we're just saying, hey, set it to a specific size. Now I got to go back and look, and I don't think there's anything that says it has to be a basic dimension. Maybe there is. I'll post a correction if I'm wrong here, but I'm just trying to find the example they give in the ASME standard is like this weird, like Pac-Man looking thing where they're controlling a non-opposed surface with profile. I don't really feel like drawing all that up there. Again, it's new for 2009, and with this Pac-Man looking shape, basically they made it so profile of a surface can have a material condition, but only sometimes, and it's kind of a nightmare. But that's how I would understand this basic, right? Setting the datum simulator at the basic dimension or the basic size. In this case, I would take it to be the middle of this plus or minus tolerance. Though it's not quite basic, I think it kind of gets the job done. Tangent plane modifier. Cool. Okay, so a question here. How do you apply perpendicularity to a shaft to the base so the mating part should be seated flat on the base while ensuring the virtual condition is met? So I think what we're saying here is we've got a part like this, and we've got like a donut part, right, that fits over it, something like that. I think the key is if you need the flat parts to be flush, like it's sealing or something, those need to be the primary datum, right? That's going to be your best way to do it, and then you're going to control the diameter to that, right? So when you set your virtual conditions, they're not going to get kind of squirrely on you. That's exactly how I would do that. Wonder. Okay, that looks pretty good. So I changed the opacity on some of these graphics, so they shouldn't be so distracting there. Okay, guys. Well, we're about 10 after, so I'm going to wrap it up pretty soon here. Thank you guys for the great questions and joining me. I'll be posting another video sometimes this week about the MMC symbol, and I'm working on some other stuff as well. So feel free to shoot me questions by DM. You can look up my email on YouTube. I don't like to post it publicly because I don't want to get scooped up by the scam whatever who just like comb the internet looking for email addresses. So it's not a secret or anything, but I can't just post it. All right, yeah, thanks, Brian. Okay. So wait just a second here. There's like a 30-second delay with any questions or anything that come in. But yeah, thank you everybody for showing up. Sorry about the audio issue earlier. I'm still kind of working on it. All right, yeah, you're welcome, guys. Cool. Yeah, you're welcome, everybody. Yeah, I'll see you next Monday, hopefully. Cool. Okay. Not bad. Looks pretty good.